So good morning, everyone. So before I get started, I just want to thank the Pune Tech community team for inviting me to speak today. And I've been attending a lot of these community events for quite a while now, and I've learned so much from all the tech enthusiasts and professionals here. So it's really exciting, and it's honestly surreal to be present as a speaker. So a bit of background of mine is I'm in my final year of college and I'm pursuing my degree in AI. And currently I'm an intern at HSBC here in Pune. So as you can see, the topic today is about multi-agent systems and how basically they coordinate and are scaled up for an enterprise level. So, over the last few years, you can see that AI has evolved at a very incredible pace, right? And every few months, we have seen a new generation of models that outperform the previous one. So we have GPT-4, Cloud Opus, we have Gemini 2.5 Pro, we have OpenAI's O3 and O4 models, reasoning models to be particular. And each release has pushed the boundaries of what language models can do. And today, these systems write production quality code, right? They solve advanced mathematics, they summarize research papers, and even assist scientists with complex reasoning tasks. And it's fair to say that we've entered a sort of era where model intelligence is no longer the biggest surprise that we can see. So, what's even more interesting is how the conversations has changed. 2 years ago, we were talking about models that were obsessed with benchmarks, right? So which model has the highest reasoning score, which model generated better code. But now today, the questions are becoming less important, and what we're talking about is how they coordinate, right? Because enterprises aren't asking which model is the smartest. So the question is how AI systems can actually help them run the business more effectively. And it's a very difficult challenge, and it's very different as well, because business problems, they rarely begin and end with a sort of single prompt, right? So they involve multiple applications and they involve enterprise level data, they involve approvals, rules, and people work towards building a sort of common objective towards it. So these sort of questions can be answered they don't require generating a lot of text. This requires more of a coordinated sort of structure and team. And that's exactly where the industry is moving towards beyond standalone language models and how we're modeling towards coordinated AI systems. So instead of building one sort of model that tries to do everything, we're beginning to build systems where intelligence is distributed across multiple components that are working together. Yeah. So the evolution of enterprise AI, right? So it can be understood as three distinct phases that I've mentioned here. So the first phase was the search era. So obviously AI primarily helped people locate information faster, right? So we had search engines, we had recommendation systems, we had enterprise level search platforms and document retrieval systems that all focused on answering one problem, which was finding the right information, right? So, but humans still had to interpret the results and make decisions and complete the actual work. The second one is the large language model phase, and fortunately or unfortunately, this came right after I completed high school and before I started my engineering. So to be fair, it's pretty much one of the best teachers that I ever had. It had to summarize all my textbooks if I had an exam the next day, and even I took help of Google Notebook LLMs. It's really brilliant how these sort of um, softwares have amazing capability towards it, and these models became capable of summarizing sort of contracts or writing softwares and translating languages. And the interface between humans and computers became conversational, right? So it made AI more accessible. And then now we have the agentic era, of course. So the focus is shifting away from simply generating intelligent responses and towards building systems that are capable of carrying out complete business objectives, right? So rather than replacing language models, the new sort of generation builds on them by extending intelligence into execution, right? So as impressive as today's sort of frontier models are, so intelligence alone doesn't automatically solve enterprise level problems. So this is one of the biggest mindset shifts happening in the entire AI engineering world today. And if you consider how complex work happens inside any organization, right? So preparing a quarterly business review or investigating a production incident or reviewing a loan application all involve multiple stages, and information comes from different systems, right? So we have decisions depend on sort of policies. You have some tasks require verification before moving forward, and other depend on results produced early in the process. So recent research, if you talk about it, we had Microsoft's Magnetic One project, which sort of demonstrated that complex objectives are often solved more reliably when a sort of work is broken down into coordinated stages rather than one model doing every single thing, right, in a single pass. And similarly, you had Google's co-scientist research that showed how specializing reasoning processes can outperform single-shot generation on scientific discovery tasks. So the lesson is becoming very clear here, which is for many sort of real world problems, the challenge isn't producing an answer. It's about managing processes that lead to an answer, right? So this is sort of why modern AI systems need capabilities beyond reasoning. So they must interact with enterprise applications and they work with the business level data, coordinate multiple steps, and maintain progress forward and objective. So even though intelligence remains the foundation, but by itself it isn't enough because sort of enterprise AI succeeds when reasoning is combined with you have execution, coordination, and reliability. So the realization naturally leads to the next step of the entire AI sort of architecture, where specialization becomes more valuable than asking one model to do everything, right? So once an organization has realized that the enterprise work is fundamentally a process rather than a single prompt, another realization quickly followed, which is expecting one AI system to do everything isn't very practical, right? So that's why, as you can see, you have intelligence in isolation versus intelligence in coordination. So even if you think about how, say, for example, a hospital, right? So the hospital won't have one single doctor performing surgery. You won't have him doing your insurances, managing the pharmacy, or scheduling appointments, right? And you won't have a software company having one engineer design the entire product or write the backend, test the application, or review the security. So every successful organization would have a sort of, you can say, a specialized agent. So that agent would specialize in its particular task, right? And these sort of agents would coordinate with each other in order to solve the business statement. So the same sort of principle applies to AI as well, right? Um, if you can see, you have different models that outperform in certain tasks, right? So you have the Cloud Opus O3, O4 models that are very good at reasoning. You have certain models that are really good at coding level tasks. You have multi-model sort of agents which work well with texts and images. So you sort of pick out, depending on the task, the sort of agents that you want for that problem statement. And then you narrow it down to get a proper team that I would say that would end up solving the problem that you are encountering. And again, another point that I would want to bring out here is a lot of companies are increasingly combining frontier models with the sort of lightweight models that we have. So in a way that they can balance the sort of cost, speed, and quality that they can bring out, right? So the shift is also driven by economics because frontier models are incredibly capable, but they're also very expensive to run, right? So if every email classification database lookup or a document validation uses the largest available model, you would have your operation cost increase rapidly, and you don't want that, right? So instead, enterprises are designing systems where each component performs only the work that it's best suited for. So rather than building one AI that tries to become an expert in everything, you have modern systems distribute expertise across the specialized components, right? So the next scaling law. So for almost a decade, you could see the progress in AI followed a very fairly predictable pattern, which is if you wanted better performance, you train larger models using more data and more compute, right? So this became known as the scaling law of deep learning. And for many years, it worked pretty well, I'd say. But every generation simply became bigger than the previous one. But over the last year or so, I realized that there's separate sort of something interesting that's going on in this field, which is instead of only investing in larger models, you have researchers who are focusing on how intelligence is organized after the model has already been trained, right? So OpenAI introduced reasoning models like O1 and O3 that spend more compute during inference before producing an answer, right? And then I think, if I'm not wrong, Anthropic also introduced extended thinking. And Google has also been exploring agentic reasoning systems, while even Microsoft has demonstrated coordinated multi-agent coordination execution systems. So, in other words, if I have to say, the progress is no longer coming only from building bigger brains, right? It's increasingly coming from building better systems around those brains. So this is why a lot of people have been moving towards the new scaling law or scaling dimension. Rather than scaling only model parameters, we are also beginning to scale reasoning, planning, and memory tools. So the intelligence doesn't just reside on the model anymore. It emerges from how different components interact with one another. So it's very similar to, I'd say, how organization grows, right? So a startup with five brilliant engineers can only scale so far, but eventually success depends on less on hiring and smart individuals and more on creating better teams, right? So you have clear responsibilities and effective coordination. So I'd say AI is following a similar trajectory here, right? So one of the most useful ways to think about modern AI systems is to kind of stop imagining a single assistant and instead imagine an entire project team. All right. So every successful team operates through clearly defined responsibilities rather than everyone doing the same job, right? So one person would plan the work. You would have a specialist, which would contribute their expertise, and then you would have reviewers to validate the results, right? So a typical AI team would often start with a planner, all right? So rather than immediately solving the problem, the planner would first break a large objective into a smaller, manageable task. And this is very similar on how an experienced sort of project manager creates milestones before the work begins. And then these tasks are assigned to specialized agents, right? So that's what I was talking about in the previous slide. So you would have a specialized agent which would work on the task given by the planner. And then you would have, like, say, one might retrieve the enterprise knowledge. So another would analyze structured data, another could generate code, APIs, or sort of build on these business applications. And each specialized agent would focus on a domain where it's most effective instead of attempting to solve everything. And then you would have the reviewer or the validator. And this is my sort of favorite part of an AI team, because if you look at it, it's very similar to sort of reinforcement learning, where you would have the reviewer who would look upon the outputs on the previous AI agent and would sort of ensure that the final result would satisfy the policy and the business objectives. And before the results are delivered, so you would have another agent who would check the work if it's complete or not. And it's a sort of feedback loop which would improve uh, reliably, and especially for tasks that are very complex. And Uh, to be fair, there's a lot of multi-agent frameworks. You have Microsoft's AutoGen and you have LangGraph. You also have Crew AI, and I think someone's going to be talking about that in the further sessions. So all of these follow variations of the same idea. So you would have the exact implementation, but it would differ, based on the complex work, and it's going to be divided more than centralized. Right. So coming to dynamic agent teams, so one of the biggest difference between, I say, traditional software and a modern AI system is that they're no longer static. All right. So in traditional applications, the workflow is always predefined. And if you click a button, the same sequence of operations run every single time, right? So, but in real world operations, or business problems, there aren't always predictable, right? So every customer request is going to be different. You will have every investigation different. Every workflow requires a completely different combination of skills. So that's where the dynamic agent teams come into picture. And instead of permanently defining which agent participates in every task, you would have modern systems assemble a team based on the objective that they're trying to achieve, and you can think of them as like a consulting firm, right? So if a client approaches them with a cybersec problem, they'll bring in a bunch of cybersecurity experts. And say if it's a supply chain issue, they'll assemble a sort of logistic specialists. So the team is centered around the problem, and it's not the other way around. So AI systems are beginning to work in sort of exactly the same way. You would have a request, investigate, say, around a financial fraud issue. So the agents will be specialized in transaction analysis, say, customer history, sanction screening. And the very next request could be something completely different, requiring document understanding or legal reasoning or code generation instead. So you could think of this as, gathering the sort of best superheroes for your team and assembling your own sort of Avengers to complete your task, right? Yeah. Yeah. So the next one is the anatomy of an intelligent agent. So a useful way to think about an agent is to compare it with a new employee who has just joined an organization, right? So intelligence alone isn't enough for that employee to be productive. They need the access to the company knowledge, the right software, business process, and even enough context to make informed decisions, right? So without those, even the smartest employees can't contribute effectively. So an AI agent would work around the same way. So you would have at its core the language model, which provides reasoning and decision making as well. But surrounding the model are several other capabilities, right? So an agent needs memory, so it can retain important context across interactions, and sort of, understand on what to basically infer while giving outputs. And you would have tools, so it can interact with APIs, databases, and enterprise applications and external services. And obviously, you would need knowledge, often through you have techniques like RAG, so it can access the current company information rather than relying only on its training data, right? And finally, you will have planning, right? Allowing it to break complex objectives into manageable steps instead of sort of responding impulsively to the first instruction retrieves, right? Yeah. Coming to different multi-agent design patterns, right? So by now we've seen that one agent isn't always enough, and you know, once you have multiple agents, the next question is how do you organize them, right? So just like how software engineering has multiple design patterns, so multi-agent systems also have different patterns depending on the problem that we're trying to solve, right? So the first one is the plan executor pattern. So this works pretty well for simple workflows. So you'll have one agent that looks at the request and it breaks it into smaller tasks. And then you'll have another agent which would carry out the task. And it's simple and it's easy to understand. And you'll find this in many real world use cases. And sometimes you'll need a sort of supervisor, right? So instead of every agent talking to every other agent, so you'll have one agent that coordinates the whole workflow and it decides which agent should work and on what task, and it keeps track of the process and makes sure that the final answer makes sense, right? So it's very similar to how a team lead would manage the entire software project. So then there are situations where speed is important, and instead of waiting for one task to finish before the next, several agents can work in parallel, right? So that's pretty much brilliant. And one agent would analyze, say, the sort of sales data, another would check the customer feedback, and another would look at the market trends. So while another would prepare the presentation, right? So since they're all working together, the result is faster. So I'd say there's no single best pattern. The right choice would depend on the sort of use case that we're trying to solve. But the good thing is that we have frameworks like AI Foundry, LangGraph, and AutoGen, which would support these sort of patterns, right? So developers can focus on solving business problems instead of building everything from scratch. Yeah. So yeah, a couple of years ago, everyone was talking about prompt engineering, right? Especially during my college, it was all about prompt engineering as an entire new field and becoming prompt engineers in the future. But and people would think that if you wrote the perfect prompt, you would get the perfect answer, right? That's pretty much changed right now. And the bigger challenge is giving the model the sort of right context rather than the right prompt. So you can think of it like if you're a new employee joining a company. So even if you're very talented, they won't know your products, right? You won't know your customers, your internal tools. And before you do any good work, they need access to sort of documents, previous mails, project history, and company knowledge. So AI works around the same sort of way. So instead of depending only on what is learned during training, you have modern agents that retrieve information from databases, documents like RAG, query databases, call APIs, remember previous conversations, which is very important, and even use the sort of user preferences that you have. So all of that sort of becomes the context before the model actually starts reasoning, right? Um, that's why people are talking about less about prompt engineering and more about context engineering, right? So in many enterprise applications, the quality of the context that you have is a much, much bigger impact than the wording of the prompt itself. So if I ask an AI, what's our leave policy, right? So a normal language model might give a very sort of generic answer, but an agent that is connected to the company's HR documents through RAG or any sort of way can retrieve the actual policy and give me a correct answer or a response. Yeah. So for a lot of years, it followed a very simple idea, which is if you want a better model, make it bigger, right? So if you have more parameters, more training data, if you're rich, sort of have more GPUs, you get better performance. Um, that approach gave us some incredible models, but recently the entire focus has been shifting. And instead of making the models larger, we're making it think better. And I'd say if you use models like O3 and Extended Thinking 2.5 Pro, we've noticed that they sometimes pause for a few seconds, right? So if I use GPT or Claude, it just stops at thinking and just gives me three dots. And then I have to wait for a while before it really answers or gives me a response. And initially, I thought it was a problem. And why isn't it, sort of giving me a response quick? But then I realized it's sort of giving me a better response. That's what we call inference time scaling, right? And that's where the shift is happening now from training time scaling, right? So the newer reasoning models work in a very same way. So they break the problem into smaller steps and they consider different possibilities and then they provide a final answer. So you have research over the last years has shown that reasoning can improve the performance and on complex tasks without simply making the model larger. And that's especially useful for AI agents because agents don't answer just one question, right? They make decisions, they plan workflows, and they use tools. So better reasoning means better decisions and fewer mistakes. So it makes the AI in the long run more reliable. So I'd say the future depends on building, models that have better inference time, better thinking, more than just bigger models, right? Yeah. So the rise of Internet of agents. So if I start on the left, you can see we have Agent A and Agent B. Just give me a second. Yeah. Yeah. So you have Agent A and Agent B, and you can think of this as two different AI agents, and each have their own responsibilities or different tasks, right? So inside each agent, you'll notice something called an MCP client. And this is the part of the agent that requests the access to the external tools or data that we have. And it doesn't directly connect to the databases or the APIs. So instead, it sends the request to the MCP server, which you can see on the right. So you have MCP server A, server B, and server C. And each of these MCP servers act like a sort of adapter or a bridge. Okay. So one server might connect to a company database, another might connect to a Google Drive or Slack or Teams, and another to internal business applications. Okay. So the agent doesn't need to know how exactly each system works. And that's the sort of biggest advantage that we get with MCP here. And if you look at the orange box in the middle, you could see something known as A to A or agent to agent communication. And this is something that's completely different from MCP. So while the MCP would help the agent communicate with tools, you would have A to A, which would help agents communicate with other agents, right? So if agent A realizes that agent B has the right expertise, it can delegate work to agent B and share context and exchange updates. And then it would receive the results back. So that's why you see things like task management, capability discovery, and secure collaboration in the middle. So a very easy way to remember this slide is if you have MCP, it would connect the agents to the external world. And if you have A to A, it would connect agents to other agents. So when you can combine both agents, you can access enterprise tools, company data, cloud services, and it would collaborate with other agents. Yeah, so now we also have to understand how the agent reached its decision, right? So for example, what prompt did it receive? Which document did it retrieve? Which tools did it call? Which sort of model did the agent use? And how long did it take? So if the answer was wrong, we should be able to trace every step from start to finish. And this is very important, right? So this, what we call agent observability, and it helps us to measure quality, right? So did the agent retrieve the correct documents? Did it hallucinate? And we want to continuously evaluate these things and improve the system over time. So another important area is cost, right? We all know that calling large language models isn't free. And if an agent keeps making unnecessary model calls or repeatedly query the same data, costs can increase very quickly. So observability helps us understand where time and money are being spent so that we can sort of optimize the workflow. And observability is also important for governance, right? So in many industries like banking and healthcare, we need to audit trials showing exactly what the AI did and why it made a particular decision. And this is also very important in, I'd say, very risky fields like banking and sort of financial crime and um, sort of domains where risk is pretty much a huge concern. So you wouldn't give full flexibility towards an agent to do its task. You would also require to observe what it's been doing, right? So observability isn't just about fixing bugs. It's also about making AI systems that's more reliable, transparent, and ready for production. Yeah. And in the end, we would talk about how trusted agents sort of combine into collective intelligence. So obviously, talking about how we sort of manage agent systems, we also have to talk about trusting them with design, right? So we sort of have to guardrail the agents so that they stick within the business requirements, stick within the guardrails that we have or the company organization include. Then we have human AI collaboration. We don't, so the main objective isn't about, replacing humans. I'd say it's about people who know how to use AI agents um, in a really good way, right? So you have to be creative, you have to be make good decisions while using AI agents. And then this would lead to collective intelligence as well, right? So you are using intelligence provided by the agents as well as your specialization. So the ecosystem becomes smarter than just a normal individual human agent or system, right? So you're talking about collective intelligence. And then obviously production AI requires continuous monitoring and then human oversight. Again, a very, very important thing is about security and governing the sort of intelligence and capabilities, because if this thing gets into production, it's tremendous on how much capabilities that they can have. And it's very important to govern and sort of guardrail them. Yeah. With that, I'd like to conclude. And again, I would like to thank everyone for listening. And it's been a pleasure listening to all the other enthusiasts and conversations. And thank you. If I have any questions, you can ask.
All right.